Hey there, thanks for listening in and welcome to another Ellipsis Drive podcast. Here we dive into the stories of people, companies, and technologies that transform and empower spatial data-driven industries. My name is Rosalie van der Maas, and with me today we have Stefan Amberger, co-founder of Tilebox. Welcome.
Thanks for having me.
It's my pleasure. So over the next 25 minutes or so, we will be talking about simplifying spatial data workflows and collaborations. But before we do, what should our listeners really know about you and about Tilebox before we dive in?
So my background is in high-performance computing. This is not the first time that I've built satellite data processing pipelines. I've been working in this industry for about 15 years and seen all the challenges in the past of what goes wrong, what can go wrong, what the emerging properties are, or the emerging, constraints are when building these kind of platforms. And so as a result, or as an answer to that, we created Tilebox with the goal of unlocking the potential of the space sector in the sense of like remote sensing data, be that Earth observation data, or looking outwards, space debris detection, space domain awareness. All these aspects need data management. All these applications need data management and workflow orchestration, be that in orbit or on the ground. And this is what we're building with Tilebox.
Great. So could you comment on what you're seeing as the status quo in existing spatial data workflows within this space industry?
Yeah, there are some initiatives that are bottom up. There are other initiatives that are top down, trying to standardize, harmonize different. There's definitely a lot of work towards making access to data more seamless and making data more accessible. When it comes to processing, there's always the limitation of usually there's the standard way of doing things is either people start building their pipelines in-house and hope for the best and hope that other industries tools and open source tools work for their use case as well, or you have as an alternative, you have platforms that subsume, so you upload your data and you hand over the keys, and then you get the result basically, and somebody does this for you. You lose a little bit of control, and the best or in the ideal case, you keep control, so you have somewhat like a framework to be sure that you'll be able to reach the resilient goal of a resilient workflow that's scalable, that works across clouds and across environments now for data fusion use cases that might come in the future and all these things. And that's a tricky goal if you use tools where most tools are like based on Kubernetes or based on some like single cloud environments. But yeah, this is where we do see standardization. I mentioned bottom up and top down. Stack service, obviously, bottom up, an emerging standard. You see activities from government, from agencies, where they're trying to standardize workflows and processing environments. And for sure, it's difficult when entering this industry to choose the right tool and you kind of have to learn all the tools and then make a decision in the moment of what's the right tool for the job. That's tricky for sure.
Yeah. And you mentioned the need to for example work across multiple clouds and to do a lot of data fusion, and there's of course a lot of collaboration around this. Like a lot of people are touching this data, a lot of systems are involved in various processing steps. How does that tie into these existing workflows, like the concept of collaboration between both people, teams, organizations, and systems?
So there's the component of of data, obviously. So you want to bring algorithms to the data, even if like different institutions or nations or satellite programs are working together. You want to bring the algorithms to the data and not have to like duplicate the data and then bring it all into one location and process it there. So that's one aspect of collaboration where it's important to be able to distribute and or federate algorithms. And another one, obviously, and this is my opinion a little bit, is that modularity and clear interfaces are the way actually, and code reuse is the way that software engineers have managed to reuse code and have managed to collaborate really well with. In the space sector, I think this is arriving now. So there's lots of software best practices are entering the space sector now. This software is always like, if you're building a satellite and you launch it and you just build the spacecraft that's operational, how hard can software be? How hard can it be to write the pipeline? So it's underestimated oftentimes, but we see that this is starting to get better, and the space sector is picking up also code reuse and clear interfaces. And this is what we try with our cataloging solution as well, which is statically typed, and you can generate your clients and use data sets of other that other researchers or other companies created without surprises. And the same with the workflows. So workflows are typed, and you have clear input and output parameters, which makes it easy to reuse that code and write modular workflows, maybe even integrate different solutions, like integrate different algorithm providers. You have one step, like level 0 to level 1. You have one partner, and level 1 to level 2, you have a different partner, and you still have a resilient, you're able to wrap those algorithms and create a resilient pipeline by parameterizing these algorithms and chaining them together as a Tilebox workflow.
That makes sense. So you actually commonly see with users of Tilebox that indeed they have like a more complex sort of partner landscape in which one organization indeed takes care of level 0 to 1, someone else from level 1 to 2, and then perhaps the internal team creating analytics. Is that like, are you enabling like a nice continuous workflow there where data just, goes through that smoothly?
Yeah, for sure. So depending on how the algorithms are structured themselves, you can more easy, like sometimes these are old, so this is like odd outliers, no, but sometimes you even have like old Fortran libraries that are like really optimized to the T for a certain atmospheric correction or certain like algorithms, and then integrating that is super important to bring that into a common modern workflow that doesn't depend, that can handle these kind of artifacts as well. And yeah, we do see there's specialists for all kinds of sub components of workflows for Earth observation data, especially if it's from level 0 or the higher levels. Obviously, you have oftentimes providers that can do everything, but if you start from scratch, there's so many different components like radiometric correction, geometric correction, terrain correction, all the CalVal aspects that come into play there, that where some parts you might want to do in-house, other parts you might again have partners for. And then yeah, so definitely more than most single providers can reliably offer.
Yeah, that makes
Especially if you want if you want to be able to tweak it a little bit.
Yeah, and if you want it to be good, like it's a very broad range of skills you need to bring to the table. So it's likely that you
Right.
won't find everything in one team or in one partner. So what are like the key technical, you already touched on some of them, but what do you consider the key technical challenges in overcoming like the creation of this collaborative environment that Tilebox supports?
So mostly it's compatibility, high quality metadata structuring for efficient queries, fast queries, the use of the automated parallelization such that people don't have to care about that. Um, Obviously, and way to structure or to run workflows that you can execute the workflows on your notebook for development and then use the same code to deploy it as a service or to deploy it in the cloud, in a cloud native infrastructure. And at the same time, the ability to backtest algorithms in a batch processing manner. So usually you start like bigger jobs on data archives to test a certain algorithm or backtest it on existing data, and then rolling out that as a service. So that oftentimes this transition is quite a big one, and you have certain researchers or research institutes or algorithm providers even often that work very much in this batch processing manner, that's the mode of operation that they have because this is how you develop an algorithm. But then as a satellite operator or as a service provider, you actually want near real-time processing, and you want to include those or algorithms and execute them on a continuous basis. And this distinction that sometimes scheduling systems are very different when it comes to that, or it's not composable. Like you parallelize your algorithm in a way that works well for batch processing, but then you figure out when it comes to operationalizing that, you figure out, oh, that actually doesn't work very well using these systems, or it doesn't compose with the other components, and so we make that go away. So this has to be the same in the end, operating it like this or like that.
Yeah, like I can definitely follow that logic and also those challenges. Like we at Ellipsis Drive are seeing industry struggle with similar challenges downstream from you, though. Like you clearly have a focus on really bringing raw data to a stage that is usable with indeed a collaborative ecosystem of partners and allowing your clients to effectively leverage those. So that's very interesting. So aside from the technical challenges, what is the business impact of the transformation that you're enabling here? What does it mean for your clients?
Mostly efficiencies across the board. So that unlock in the end business value. So that's goes all the way from less debugging because the tools just work, like the spatial temporal index works over the anti-meridian. You can load tens of thousands of metadata elements even for large scale processings, and you don't have to um, struggle with lower performance services of metadata management services, or so from that or the same with workflow orchestration, increased performance, lower overhead, faster iteration cycles, better time to market, and the ability to try out more, to diversify to get developers onboarded faster, and um, and get to a product that the customer actually that provides value faster, and then operate that reliably. So less manual labor, and better SLAs. So we can focus on the commercial side of things instead of having people tied up in debugging or rewrite routines because things keep breaking.
So in short, would it be fair to summarize that as enabling satellite operators that have found the partners that work well with them to bring their end product to market quicker, just because everything comes together much more smoothly? Is that fair?
Yeah, that's fair. Yeah, this is a good summary. And that goes for on orbit as much as it goes for on the ground. So Tilebox works as a daemon in orbit as well. And you have the same issues in the end. Nowadays, with these modern compute modules, they have the same issues in orbit that you have on the ground. And then just compressing all that and getting to a high quality data product more quickly that you can then publish and create end user applications that you visualize with Ellipsis Drive and you share like that. This is super important. Yeah, it's
So
the core.
So to sort of work towards a conclusion here, can you walk us through like a workflow of how different pieces can come together and at the end of the day sort of end up in the hands of an end user? Can you sort of draw that picture?
Yeah. Like starting from scratch, you launch the satellite or the constellation, you calibrate your payload, you do that more quickly because you downlink the first images, you iterate on the parameterization of your calibration routine, quickly uplink that configuration again. You have a nicely calibrated image. Then you go onboard the spacecraft. The workflow would be like you reduce the data volume that you need to downlink, so you save operational costs. You can do that by removing clouds in orbit, selecting the bands that are interesting for the customer, cropping the area of interest, compressing the data, and that gets downlinked. You ingest it, so all the telemetry data, auxiliary sensor data, raw imagery, ingest this into your statically typed data sets. From then, kick in the automations that you created, which is basically the workflow that transforms the level 0 imagery to level 1C, level 2 imagery, applies all these corrections. If it happens to be that the image is taken over over an area that contains a ground truth that you can calibrate against, you can automatically trigger the cal-val pipelines. So that can be dynamic within the workflow. And then when it comes to level 2 products, or maybe you have like a weekly aggregate or a level 3 product that you generate with another automation, and then you have your core data. That's the center, or how do you say it? The meat of the company without saying meat, like in this case, like the valuable thing, the valuable piece of information that you use, the raw data basically that you use to create end user applications. And then connecting that all the way with the end user. There are multiple modes of interactions here. Either you take that level 2 or level 3 data product, you filter out relevant pieces of information and send notifications to customers. That's the best case scenario. So in that case, the end user doesn't have to do anything for themselves, and they gain the benefit of the satellite application. Examples for that are wildfire monitoring or methane monitoring. Any monitoring use cases, basically, you want to make sure that it's not just pull based, but potentially push based. And alternatively, the customer kind of logs onto a portal and maybe selects. I don't know. There's so many use cases. Like you select an area of interest that can trigger an on-demand processing in the background, and return the report or the actionable insight based on that. So there's like all kinds of, some components of these workflows are more event driven, and that would be for sure all the way up to level 1C, level 2A. And then there are some, maybe if you have a level 3 product as well. And then some are more on demand. So you don't want to create level 4 products or like for the whole globe. If maybe you want to use some parameters that come from the request itself and do that on demand.
Makes sense. And that brings us full circle from indeed A to Z. Thanks for that wrap up. That's actually quite clarifying. So what are any closing thoughts before we wrap up? Like what are the milestones that are around the corner for you that are exciting to mention?
Yeah, so we just launched basically our custom data sets, where now it's a matter of a few mouse clicks and a few keystrokes basically to create fully scalable, world-class performance data catalogs. This is exciting. We've seen this now at the Living Planet Symposium, seen this to be a big bottleneck actually for those companies that are at scale already, but maybe don't have like huge venture funding to create in-house solutions, and want to get to market quickly. That's a big one that we're excited. And for further deliverables, one feature we're prototyping that has quite some ramifications is federated computing. I can't guarantee that we'll launch that 2025, but it's that would mean that you can host certain algorithms co-located to your own data without you don't have to expose the algorithm, but your customers can use them because the interfaces are clear, can use them as part of their workflows, and create higher level workflows with your data without having to load your data, without having to understand the algorithm that you're applying, but they can parameterize it and use it as part of their workflows. And that has impacts when it comes to AI, that has impact when it comes to reusability and commercialization of data products. And yeah, we're excited about that.
Great. Yeah, should definitely touch base on that when the time comes, perhaps in 2025 and otherwise early 2026.
Yeah.
We'll keep you to that. Yeah, so with that, our time is up. So thanks so much for sharing your story today. And if you're tuning in and you'd like to know more about Stefan or Tilebox, we'll leave links in the description so you can find everything you're looking for. Thanks for being here with us today, and until the next one.
Thank you so much.